Hello there, this is Pega10 and welcome to the third intermediate LUA tutorial. Now, in this tutorial we're going to be covering the basics of object-oriented programming. First of all, I should point out that we are using RBX Studio 2.0, which means we have auto-tabbing, hooray, but it also means I can't zoom in or out. This is me holding down Control laser mouse work, it's not going to work, so I'm going to have to just zoom in Camtasia. It might be a different quality or whatever, but object-oriented programming, what is it? And why is this useful? Now, object-oriented programming is a programming concept which basically you allow to have groups of data and methods represented in an object form. A good way of thinking of objects, because these are objects and these are object-oriented programming, is Roblox objects. A Roblox object is, for example, this script. This script object has properties. It has linked source, name, parent, archivable, disabled, class name. These are all properties of the object. It also has methods. It also has the method clone, the method destroy, the method remove, with the method get children. This object has all of this stuff. A good way of thinking of object-oriented programming in Roblox terms would just be custom objects, custom instances. These are all objects. We can create our own objects. So with object-oriented programming, for example, if we wanted to have an easy way of storing and controlling zombies, instead of having to manually do the zombies, if we programmed it correctly, we could have local z equals zombie new, for example, and then we could change the zombie's health by like this. So instead of having to do we could make the zombie check for the humanoid. Remember, if you're used to programming with zombies or humanoids in Roblox, then you'd usually have to do something like find first child's humanoid, then check if it has the humanoid to make sure it doesn't break. You can make that happen in the zombie, so you can say z.health equals 50. Then you can add some methods into it. So a method in the zombie might be z. You could have a copy method, because remember, if you clone zombies with just a Roblox's clone method, sometimes they break, so you could make this method prevent that. You could have a dance method, which then you call this on the zombie and it would dance. You could have multiple zombies. You could store them in different ways. You can store this zombie object, which is entirely your invention, in a table, and you can do whatever you want with this zombie object. Today I'm just going to be teaching the absolute basics of object-oriented programming. This will use what we've covered in the previous two tutorials for metatables. We're going to need metatables for this, and we're going to need tables, and we're going to need logic to make this work. And it may seem a little confusing at first, but I promise you'll be able to understand it once I've gone through a bit. So the first thing we need for object-oriented programming is a table. So I'm just going to make a basic object. We're just going to call it object. Now this object is going to store all of the methods, those are the functions, the methods of the object inside this table. So for example, the methods, one method would have to be object.new, or object new, or object create, to create the object. And we could have other methods. For example, add. We could have a method print2 and it would print 2. This is a completely pointless exercise, but we can do that bit anyway. So first, I'm just going to create a method, which is we're going to use a colon to create a method. I will explain why in a second. Print2 and print 2. That's a simple function. Now the reason I've used a colon is because when you're using tables and you're putting a object as a table, if you're making a function inside a table with a colon, it actually automatically sets the first argument. So although it doesn't look like it has any arguments here, it actually does have an argument. It has an argument called self, and that is the object, that's the actual table you call the function on, because we're not going to be calling it directly with this. We're not going to be calling the function on the object without. We're going to have to create multiple instances of a table for the object. So for example, like I showed you with the zombie, if I did local O equals object new, we're creating an instance of our object. If I did this, object 2, we're going to create multiple instances of this object. We're not creating multiple instances of this table. This table is staying as one, which is why once I've created the new function, I'll understand what I'm doing here. But that's why we need to have the self argument here rather than just having it return this, because otherwise it won't sort its own data. I'm probably not making any sense. So it'll become clear once I've made this next function. This next function, first of all, we're going to need just the meta table for our object. This will become clear as well. This next function is the one that's going to create our table. This is a table that we're going to be passing around. So function object new. Can accept no arguments except the default self. Now, here's where we create the table. So this is the table that's going to have all the values in it. So local, let's call it O equals table. Now this table, we're just going to set the properties of the table. That these are the properties that every object is going to have. We're going to create. So let's set a property O dot name equals. Remember, this is a custom object, so we can name these properties or whatever we like. I'm not going to put a capital letter because pressing shift annoys me. Let's name it Obby, because it's Obby the object. There we go. This is phonetic naming at its best. I should probably exit mumble. That was loud. So we're gonna actually Obby reminds me of the obstacles in the Roblox. We're gonna leave this here anyway, but what we're going to do with this object is that this object, if we just returned this table, it's just going to create a random table with the name, which is a property with name, which is Obby. This won't have any of the functions in the object have. This won't have any of the functionality of an object. We could do whatever the hell we liked. We could remove this property altogether. No, we don't want that. Which is why we've got this meta table. Now this meta table is going to be the meta table that points towards all the functions from object. This meta table is going to control. This meta table is going to be the one where if we say anything, it's going to redirect us to the real property. It's with the index and new index meta methods, or it's going to redirect us to the function. It's going to call the function for us. Again, that probably doesn't make any sense, but here we go. So we're not going to return O. First of all, we're going to local. I don't create a new line. Local M equals set meta table, which I don't remember set meta table ever going blue. That's a new thing of Roblox Studio 2.0. And we're going to set the meta table of our object and the actual meta table here, which doesn't actually have anything in it at the moment. I'll put something in it after this. So now we have our. This is just going to create a table. It's going to set the property of. It's going to set something called name in the table to Obby, and then it's going to set the table having a meta table with this meta table, which has nothing in it at the moment. We're going to put something in it now, and then it's going to return it. So now you're going to have a new table. So what we're going to do now with this meta table is we're going to make it so that you can't add any new let's make it so that the only property you have in this table is name. You can't access anything else. For example, if we just had a table, you can do whatever you like with it. So O equal, oops. We can do whatever we like. We can set anything to anything in this table. No, we don't want that. We want it to be an actual object. We want the object to have specific properties. So we're going to have to create meta methods which prevent that from happening. So first of all, let's have the index meta method. Now if you remember, the index meta method is called whenever you try and index something which isn't there. So this index meta method wouldn't be called if we access the name property of O, because name exists. However, if you access anything else, it wouldn't. This index meta method would fire because nothing else exists except name. It's going to function table and the key. Now, so we're going to have in this section as well. We can also have different. We can add extra properties, for example. So if someone types O dot type, well, not one type. If the key is going to be whatever they so key is the key of the table that you're trying to access. So if you created, and then this bit would be the key. This bit, right, I've labelled key here. That's the key. So if key equals, let's say, type. If key equals pi, and then we're going to return meat. We're going to have a meat pi. So if anyone accesses the object dot pi, it's always going to return meat. The pi doesn't exist in the table, but because of this meta method, if someone accesses pi, we're going to return meat. If it's not that, however, and then we're going to actually access the object table. We're going to returning, by the way, this doesn't, well, this bit will actually do something that you may not expect. The object key. So what this does is it's going to return whatever's in this object at this key. So if someone types object dot hello, and then it's going to search through this object table, which is going to have all the methods. Hello doesn't exist. Hello isn't pi. It's going to go here. Object key. It's going to return whatever object hello is, which is nil. So then this is going to return nil. However, what you might not expect to happen is if you're calling a function on it. So if you have your object, if you've done this, and you do objects, and call this on it, this is going to try and run this function as well, and it will also run it with the arguments that you specify. So if you have this, it will run it with the arguments you specify. Obviously this is going to return nil because this doesn't exist, but if, for example, with object print2, what's this going to do? This, in fact, is actually going to run our print2 function. Now, why does this happen? You create an object. You create a table. You set the table's meta table to this meta table. This meta table has its index meta method set to this, which means this now, whenever we use anything in the table which isn't already in the table, so o.name would work. O.name, we can do whatever we like with that. However, o.pi would automatically return meat. We can't change that. Actually, you can, because we haven't set the new index meta method. We'll explain that later. But if we print2 like here, it's going to go, okay, print2 doesn't exist in this table. Print2 doesn't exist in this table. So it's going to go to index. It's going to now return object key of print2. Now, that means it's going to call the function object of print2, which means it's going to run this function. Which means we can now always run functions in the object table from an object we create of a meta table involving this one. Now, that may seem overly complicated, but I trust you it's not. So now we're going to create the new index meta method. The reason we're doing this is because new index means new index means we're controlling whenever someone sets something else. So at the moment we can set any random property and say hello. That we don't want this to happen. This is our custom object. We don't want people just create random properties in our object. So underscore new index equals function tab key and value. Now we need the value because that's what is going to be table.key equals value. So this, with our object here, if I just put it down here, it will be o.key equals value. Now key is this bit, value is this bit. So if key equals, say, if they've tried to set the pi, if they've tried to change what pi is, which they're not allowed to do, and then what shall we do if they try and access pi? Well, the table, which is going to be the table that we can set table. Actually, we can't. We don't want to change anything. We're just going to. If anyone, every time someone changes pi, we're going to set the name of the table. This is completely random to whatever they wanted to do. For this is a completely stupid script, but whatever. So whenever they say o.pi, pi is set to meet. o.pi equals hello. It'll set the name to hello because that's helpful to anyone. It's helpful to understanding this object. Is if you change the pi, you change the name, but not the pi. Yay. So if they don't say pi, however, then we want to just error. There's a function in Lua, error object has no member. Actually, we'll say the name of the object. So tab dot name, because remember table is the table they're calling this on. So if we did tab dot name, it's going to recall this name here, which is probably going to be obby unless they've changed it. Tab dot name has no member, and let's say what the key is. And end that one too. Okay, so now we've got a few things, and now you'll see what this does now. So if I run this script, let's leave it as this. We're going to go o dot print o dot pi print o dot name o dot pi equals pighead pi, and then we're going to print the name again, and then we're going to call the print2 function on this object. Let's see what happens. Now I have done something wrong, probably. Yep, according to the output I have. Ooh, that's new. Attempt to index global pi a nil value on line 18. Because I've said pi.name equals value for some reason. Tab.name, that's the better one. Tab is this we want to set. Hopefully some of you will have noticed that I've done that mistake. So, meet obby pighead2. So what are we doing? Printing o.pi, which o.pi, remember, doesn't exist in this table. However, because we've set it up with a meta table. This is the meta table. This meta table has an index. Because it doesn't exist, it's going to go here, which means it's going to return meet, which means this line is going to return meet, which it has done. The name is defaulted to obby because it sets the name here. It's nothing to do with this function or this function, so it's just going to print obby. And now we try and set the pi. Well, the pi doesn't exist as a property, which means it's going to go into this new index. So o.pi equals pighead, which means it's going to go here. The key is pi, which means it's going to set. We've told it to set the name to whatever value I've chosen, which means on this line, the name is going to become pighead, because then we're going to print the name here. We've printed the name, and it's printed pighead. So we've actually changed the name. This line is actually changing the name. And print2 is just calling a function which prints 2. Now that's the very basics of object-oriented programming, but we haven't finished yet, because I'm just going to show you one more thing of having properties which you don't want people to access directly. You don't want people to, so for example, a read-only property. So let's say, let's have a value in this O dot we want this to be red, but not, you can access it but you can't change it. So we're going to let ID not often allowed to change ID. So ID equals 1. We're going to have it ID equals 1 for every single time, because that's unique enough. So first of all, if we just leave it like that, whenever we access ID, it's going to be completely normal like a table. None of this stuff is going to happen. But even if we put it in here, so else if key equals ID, then what's going to happen with this? This bit, else if is one word, this bit will never run. We'll never get key equals ID because ID exists. And if ID exists, then the index meta method doesn't run. So what we're actually going to do is we're going to make this something hidden. So we're going to call it underscore ID, which means if no one's going to, the property we're going to have is not going to be that. We're not going to have O dot underscore ID. That's silly. We're going to have the property as O dot ID, which means now this will run. So if someone indexes ID, then we're going to return O dot underscore ID. So whenever anyone says O, let's delete this bit for now. Whenever anyone says O.id, it's going to go ID doesn't exist in this table. It's going to go here, key is ID, it's going to return whatever underscore ID is. Underscore ID is 1, so the ID is going to be 1. Which means that if we try and set the ID, that's going to not work because we've set the new index to never actually allow it to change the name. So but we also don't want it to change, to display this error message, because ID does exist. If we just did it this way, it's going to error. For example, if I did this at the moment, I'll play it and it will error Obby has no member ID, because this is the error we've told it to. This is the error we've told it to play. However, it does have a member ID. We want it to have a pseudo member, like we've done. So if we just go print O.id, it will work. Attempt to let global O a nil value. I didn't think O was a nil value. Oops. What have I done wrong here? Oh, line 31. Oops. Line 31's here, sorry. Tab.id. It's going to print 1. It's so we want it to appear as if ID actually exists, which means in this new index function we're going to go else if key equals if someone's an ID, then we are going to error because you can't change the ID. We want to say you can't change the ID, so we're going to have to go error ID is read only. And that is what we're going to do. So now we're going to try O.id equals 10. What happens here? ID is read only. It's not going to allow us to do that because we've set up a meta table with an object in it. Hooray! Now the last thing I want to do is I want there to be we have to have a function which changes the values. So say let's remove this stupid function. Function change function object change ID. We're going to have a function in the object which changes the ID of the object. Let's have it as increase ID. No arguments. And now this is going to add 1 to the ID. Well, let's just have that. It's going to add 1 to the ID. as I explained before, I think I mentioned this before, the object will actually have a value called self. Well, the function will have a value called self. Because how are we supposed to increase the value of the ID? We can't. What are we supposed to do? Tab? No, tab doesn't exist. There's no argument tab. If we change the object.id, no, because object's a table that holds a function. All object has in it is this increase ID and new function. Now we want to change the ID of this. Now how do we know what this is when it's calling it on this object? Well, whenever we use this method symbol with an object, it's syntactical sugar, which basically means it's a quick and easy way of having the argument of the first argument of this as self. So now basically all this means is the object that I'm calling increase ID on, which will be the object I originally created here, is going to be referenced in this function, referenceable in this function by self. So I can just change self underscore ID equals whatever the previous ID was plus 1. I can even do this, because that will read correctly. I'm going to end here. So we can't change the ID because remember that's redo, so we're going to print o.id o colon increase ID and print o.id again. See what happens. 1 and then 2, because this function increases the ID of there. So overall, again, what it does, we've created an object which holds all the functions, well, we call them methods of the object. So this is going to be new and increase ID. We've got the meta table, which points towards the object and acts as sort of a proxy to, that's not the right word, but it points towards the object. And then whenever we call new, it's going to create a table. It's going to set all the properties of the table. It's then going to set the meta table with this object and the actual meta table here, which means that whenever we access anything in this meta table, it's going to point us towards the function in the object. So we can access all the properties in this table, as well as the functions in object, as well as anything in these new ranges. We can add all the functionality we want, which means that now we have a custom object which has a read-only ID which we can increase with a function, which has a name which you can change normally, which has a value called pi, which is always meet, which you cannot change, and if you try to change it, it will change the name, because this is a really useful thing to have. In the next tutorial we'll actually be doing something useful with this. Actually I might discuss some other parts, including inheritance and further properties in this tutorial. In some later tutorial we'll actually be going into using this in part of your game. You'll probably already understand how to use some parts of it as part of your game. If you look at my GUI physics demo at my first place, that was done entirely from this. In fact, the code, I've got it open on another window now. If I show you here, I can do this. I'll just paste it down here. This code. Now, we're using my GUI physics engine. This code creates a rectangular grey GUI on the screen, which has the elasticity of 0.603, the friction of 0.05, appears at this position, and it has physics. So an object will appear that falls down from wherever it's got gravity, it will fall down and then bounce on the floor. So this is what object-oriented programs to do, and this is why it's very, very useful to do it. And if you're making a big project, you should always use object-oriented programming, because it'll just make everything so much easier and more structured. Thank you for watching. I understand that this may have been a very complicated thing to understand, but the end effect, the final effect that we've done here is actually very simple, and just the way we've done it, if you've understood the previous story, you should be able to understand it. So, I hope you've understood it. Don't forget to like the video if you liked it, dislike it if you don't, and to subscribe to me if you haven't already, and goodbye.